Reality at times can seem like an illusion. This illusion will often have you questioning what you've always thought you've known as real. What is real? What is the unknown? This has been the source of inspiration for exploration since the dawn of man. We shall not cease from exploration, and the end of all our exploring will be to arrive where we started and know the place for the first time. Some of the greatest explorers have traveled to the ends of the world to explore the unknown. We are going to cover some of these explorers and their enigmatic journeys. Let's first take a look at Fabian Bellinghausen, a Russian naval officer who led the Russian naval expedition from 1819 to 1821 in search of Terra Australis. His ship was the first to cross the Antarctic Circle since Captain Cook in 1773. During this expedition, he circumnavigated Antarctica and was the first person to sight the Antarctica continent. His orders were to explore as far south as possible and to engage in scientific work. At the end of this Antarctica expedition, he had logged about 51,000 miles forward during his journey. He was also the first explorer to reach Antarctica's coastline and have a view of its land. This is the route that he took. It had started and left from Portsmouth, England, then traveled south to Sao Paulo, Brazil, then proceeded to the 60th latitude, before beginning his circumnavigation of Antarctica. After about halfway through his circumnavigation, he had navigated down to Sydney, Australia. From there he had ventured out to New Zealand and some of the surrounding islands, before returning back to Sydney and continuing south back to the other half of his Antarctica navigation. He then finishes his journey around Antarctica, and then sails back up north to England to complete his expedition. After looking at the map of his alleged route, the 51,000 miles logged didn't seem right to me, at least not on a globe. So I mapped out the path of his expedition in Google Earth to get a more accurate idea of what this mileage should be, and as you can see, I came up with a total of about 39,367 miles. I had also read that Fabian Bellinghausen had circumnavigated Antarctica twice during his expedition, allegedly, which to me immediately set off a red flag. Why would he logistically need to circumnavigate Antarctica for a second time on the same trip when he just finished circumnavigating and exploring its coastline for the many months before? And as for the extra mileage for this second trip around Antarctica, if we reference two other modern-day sailors who have allegedly circumnavigated Antarctica, like Lisa Blair, for example, this would add another 18,500 miles to his expedition, now making his overall mileage for this expedition over 58,000 miles, which is about 8,000 more miles than what is claimed the expedition took. Where are these other 8,000 miles coming from? I also had read from several different websites documenting that Bellinghausen had claimed to never have seen Antarctica. Rather, some of what was written in his log matched what we know about Antarctica today, and if he did in fact circumnavigate around Antarctica twice, why is there not two different circumnavigation routes shown on the expedition map, as it only shows one circumnavigation route? And though Captain Cook and the British Challenger Antarctic expeditions have official detailed logs available, I could not locate any official logs available on Fabian Bellinghausen's expedition. Another problem with this would be, how would Bellinghausen be able to circumnavigate around the same 60-70-degree latitudes during the Antarctica winter, when the ice freezes over on that latitude and only an icebreaker, which didn't exist at that time, could navigate that area? There's a lot of holes in this story, and missing information that isn't available. Was whoever was in charge of organizing this expedition possibly changing the official narrative of this journey and making the claim that Bellinghausen had circumnavigated Antarctica twice to cover the fact that he was logging far too many miles for navigating around Antarctica? Could they be claiming he saw and explored Antarctica when he never actually did? There is some evidence that this had happened before with some of Captain Cook's voyage logs, as well as his route, particularly from his second voyage, which I will get into more detail later. And if Bellinghausen didn't navigate around Antarctica twice, according to the globe model and Google Earth, he would have only navigated around 39,000 miles, not the 51,000 miles that were logged. Where would these other 12,000 miles be coming from? There is a lot that doesn't add up or make logical sense, but you will notice that all of these historic Antarctic expeditions and the modern Golden Globe race share something in common. But for now, let's take a look at the James Clark Ross Historic Antarctic Circumnavigation from 1839 to 1843.
The English Antarctic Expedition. The English Antarctic Expedition was undertaken in 1839 to 1843, mainly with a view to magnetic observations and the determination of the position of the South Magnetic Pole. Two old bomb vessels, the Erebus and Terror, were fitted out under the command of Captain, afterwards Sir James Ross, with Captain Crozier in the Terror. The cruise for the second season was commenced from Tasmania, south of Australia between 42 and 45 degrees south latitude, in November 1840. The Auckland Islands and Campbell Islands were first visited and surveyed, and on New Year's Day, 1841, the Antarctic Circle was crossed in about 72 degrees easting. A few days afterwards, the two vessels were beset in the pack ice and began persevering and boring through it. By January 10th, they succeeded and were clear of ice in 70 degrees, 23 minutes south, and next day land was sighted, rising in lofty peaks and covered with perennial snow. That day, Ross passed the highest latitude reached by Cook in 1773 at 71 degrees, 15 minutes south. On a nearer approach to the land, there was a clear view to the chain of mountains, with peaks rising to 10,000 feet, and glaciers filling the intervening valleys and projecting into the sea. The land interposed an insuperable obstacle to any nearer approach to it. Captain Ross landed with great difficulty, owing to the strong tide and drifting ice, on a small island near the shore named Possession Island, in 71 degrees, 56 minutes south, and 171 degrees, 7 minutes east. Inconceivable myriads of penguins covered the surface, but no vegetation was seen. Next morning there was a southerly gale which moderated, and on the 18th of January they were again sailing south in an unexplored sea. No mention is anywhere made of extreme long days to correspond with co-equal latitudes of the north, as there necessarily should be were the Earth a globe. On the 23rd day they were in 74 degrees 20 minutes south, and thus passed the most southern latitude reached by Captain Weddell in 1823. Sailing along the newly discovered coast, Captain Ross landed after much difficulty on an island named after Sir John Franklin in 76 degrees 8 minutes south. Page 328 is The Earth a Globe, Chapter 15. On the 27th, they came in sight of a mountain 12,400 feet above the level of the sea, which proved to be an active volcano, emitting flame and smoke in great profusion. It was named Mount Erebus, and an extinct volcano to the eastward, 10,900 feet high, was named Mount Terror. Along the coast as far as the eye could reach to the eastward, there was a perpendicular cliff of ice from 150 to 200 feet high, perfectly level at the top and without any fissures or promontories on its seaward face. Nothing could be seen above it except the summits of a lofty range of mountains extending southward as far as 79 degrees south. To this range the name of Perry was given. Captain Ross then sailed along the marvelous wall of ice eastward in 77 degrees 47 minutes south, as far as 78 degrees south. This barrier was estimated to be 1,000 feet thick, and it was followed for 450 miles without a break. The whole of the great southern land discovered by Sir James Ross was named Victoria Land. Imagine, if you can, the amount of centripetal force there must be concentrated to the center of a globe or sphere to hold these mighty walls of ice and mountains of frozen material in place. Is not the statements of the prophet Job easily reconciled with the above? Hast thou perceived the breadth of the earth? Declare if thou knowest it all. Job 38:18. The waters are hid as with a stone, and the face of the deep is frozen. 30th verse of Job 26:10. He hath compassed the waters with bounds until day and night come to an end. In November 1841, the Erebus and Terror again shaped a southerly course, entered the pack ice on December 18th, summer, and once more crossed the Antarctic Circle on New Year's Day. The navigation through a belt of ice 800 miles broad was extremely perilous. At length, on the 1st of February 1842, a clear sea was in sight, and they proceeded to the southward in 174 degrees 31 minutes west. On the 22nd, they were surrounded with lofty icebergs aground, and at midnight the Great Ice Barrier was sighted and its examination recommenced in 77 degrees 49 minutes south. Next day, the expedition obtained a latitude of 78 degrees 10 minutes south, by far the highest ever reached before or since. After escaping imminent dangers in navigating through chains of huge icebergs, Captain Ross took his ship northward and wintered at the Falkland Islands. Third expedition. In December 1842, the expedition sailed from Port Louis on the third visit to South Polar region, seeing the first iceberg in 61 degrees south. On the 28th, the ship sighted the land named after the Prince de Joinville by Dumont d'Urville, and the south side of the South Shetlands was surveyed. During February, about 160 miles of the edge of the packs were examined. On March 11th, the Antarctic Circle was recrossed for the last time, and the expedition returned to England in September 1843. Thus, after 4 years' most diligent work, ably conducted and quite unparalleled voyage to the South Polar regions came to an end. Quote, 2 islands named Heard and McDonald were also visited on this wise, November 1853, by Captain Heard of the American ship Oriental. In February, they were driven southward by a gale of wind, and the first iceberg was discovered on the 12th in 60 degrees 52 minutes south. It was 200 feet high and about 700 feet long. On the 19th, the ship was at a dense pack of ice in 65 degrees 42 minutes south, and on the 4th of March they bore up to Australia. Several deep soundings were taken, the greatest depth being 1,975 fathoms, corresponding to about 3 miles. The route of the Challenger was much the same as that of the Pagoda in 1845, but more to the north. With it ends the somewhat meager record of voyages across and towards the Antarctic Circle. CRM, Encyclopedia Britannica, Volume 19, page 330. Antarctic Exploration. We understand by authentic statistics that the expedition of the Challenger and the reports of her crews cost the nation the extravagant sum of over $1 million. This, the necessary result of which that government regards with cautious proposal as to any further scientific advances for any similar expedition. And it, we believe, expressed its discouragement of the proposed Antarctic expedition in connection with the Australian government. The Challenger did not openly admit that it had searched for the South Pole in vain. Oh no, but it sailed 3 times around the world, or upwards of 60,000 miles, without being able to say that it had been fortunate enough to ascertain the existence of any such wonderful locality. Of course, it may have gone on searching as long as its timbers or platings held together, and the same disappointment must have attended its efforts. Right here, a thought or two may be suggested to the reader. Were the Earth a globe or spheroid, inside of the Antarctic Circle, the degrees of longitude could not exceed 30 miles to the degree. But if we allow them 30 miles for adversities of winds, currents, ice, etc., and multiply 360 degrees by 60, we have 21,600, in order to make a circuit of 10,800, claimed by all globularists. Yet we can afford to be more liberal. We will call the multiplicator 120, and the product in miles will only reach 43,200, a little over 2/3 of their nautical record as above, and most of this inside the Antarctic Circle. But after a circuitous cruise like the above record, and a fruitless expenditure of over $1 million, it seems quite natural for them to feel somewhat crestfallen in regard to their previous importunateness with the government. Although the record does not state that they were in search of a South Pole, but a magnetic pole. Yes, and where did they expect to find it, if they found any such thing? And what did they expect to call it when found? A suggestion here will do no harm if it does no good. We charge nothing for our advice when it is not followed. The aforesaid expedition could have made just as great a failure with less money. $200,000 or $300,000 expended in sending one expedition southwest of Melbourne and a second southeast. They would end themselves at a distance of 1,000 miles or so, the same as a rat in a barrel, and still find themselves as far from their magnetic pole as the north is from the south, the east from the west, or the kingdom of heaven is from the earth. But in the words of another, we would say, To be looking for a South Pole at the end of the 19th century just because some pagan astrologers conceived the idea of a planet Earth some 2,000 years ago, and men are yet found who pretend to accept this heathen blasphemy, is presumption in the extreme. The ice barriers which constitute the Earth's circumference extend for some 30,000 or 32,000 miles, but present no opening large enough for the passage of a seal or walrus. No alternation of long days, as in the Arctic region, but the months of May, June, and July are enshrouded in one long, dreary night. The snow never thaws, and the crash of the falling icebergs appalls the stoutest hearts. Therefore, unless any expeditions to these regions is conducted with peculiar caution and intelligence, it would very shortly end in discomfiture and dismay to all concerned. And if anything is attempted beyond the inquiry whether there is any southeast or southwest passage, no possible result can follow than loss and discredit to the promoters and cruel suffering to the parties engaged.
Captain James Cook is acknowledged as one of the world's greatest explorers.
Known for his naval expeditions and redrawing the map of the planet, Captain James Cook has long been regarded as a national hero.
Let me pay tribute today to Captain James Cook.
Ambition leads me not only farther than any other man has been before me, but as far as I think it's possible for man to go. Now, join me on this awesome journey with one of the greatest explorers, the first man to circumnavigate the Earth, the first man to find the Antarctic Circle, James Cook. Captain James Cook was a British explorer, navigator, and cartographer and captain of the Royal Navy. He was born on November 7th, 1728, and died on February 4th, 1779. During his 3 voyages in the late 18th century, Captain James Cook charted areas of the Pacific previously unknown to Europeans. The legacy of the voyages remains a highly controversial topic in many parts of the world. His expeditions took him to South America, Tahiti, New Zealand, Australia, Canada, Alaska, and many other places around the world between 1768 and 1779. And each voyage had ambitious aims at world-changing consequences. Cook's first voyage was to search for new land in the Pacific and observe the transit of Venus. His second voyage was to search for the mythical Great Southern Continent known as Antarctica. But instead, it was on this voyage that Cook's ships became the first to cross the Antarctic Circle, and his third and final voyage was to search for a sea passage in the North Atlantic. During the third voyage, however, Cook was sadly killed in Hawaii. And the impact of these voyages continues to be felt today. 250 years later, Cook's voyages remain a source of controversy, and the debate over them continues. Now, as Captain Cook stated in his voyage logs, it took him 3 years to make the first voyage, 3 years to make his second voyage, and 3 years to make his third and final voyage. Now, you have to keep in mind that Cook was a cartographer for the Queen, so he was actually mapping out the world as he was making these voyages. Now let's have a look at Cook's journey on a globe. So as you can see, these routes make absolutely no sense on a globe Earth. But, as you can see here, once we turn the globe Earth into the flat Earth, the routes make perfect sense. Now what I've done is I've traced a rough outline of Captain Cook's famous second voyage. Okay, the voyage started in Great Britain with the color bright red. The voyage started in July of 1772 until July of 1775. That's 3 years. He traveled near the outer edge for a good length of his journey. He would have had plenty of time to study how the outer edge looked with great detail. Okay, now after months and months of research, I was only able to find a copy of his second voyage in the library of the University of Michigan. Okay, now what you have to understand is this voyage was solely set on finding the continent of Antarctica. As you can see here in Chapter 2, Departure from the Cape of Good Hope in Search of a Southern Continent. Now I'm going to let you read this part of the journal for yourself. Now, as you just read, the captain said he could never penetrate the ice barrier to find the southern continent of Antarctica, because Antarctica is the ice wall around the world. And as you can see here, Captain Cook describes the coast of Victoria Land, which you can only find here on the 1892 Flat Earth map.
There has been some controversy over some of Captain Cook's voyages, particularly his second voyage and its missing information and navigation route, which we will get into more details later. For now, we are going to talk about what I believe is the most significant voyage, Captain Cook's first voyage. I believe this was his most important voyage because it had the most clear, straightforward, eastward navigation path that is nearly the exact same route as the modern-day globe races, such as the Vendée and Golden Globe races, which by today's standards would be considered a complete circumnavigation. And there are also very detailed accounts of his first voyage mileage. Entries from his navigation log that have been transcribed and are available to read. So we can make a pretty accurate comparison to the mileage he logged on this voyage and the alleged mileage of these modern-day globe races, as there is really nothing to compare his second voyage to, which is pretty much a big pile of spaghetti, and its route is in every which direction and going all over the place, which I believe is by design and was intentionally manipulated multiple times to distract people from the actual route he navigated, and also placed emphasis and importance on his second voyage to further distract people from his first voyage, but we will get into those details shortly after covering his first voyage. Let's first take a look at his First voyage navigation log. You can see that it is a very comprehensive and detailed transcribing of all of his mileage logs. We can look at a brief description of each day he was sailing out at sea. That includes how many miles were navigated for the course of that day, as well as the different landmarks that were tracked by their distance in leagues to track their longitude and latitude locations, because I was having a hard time finding much information on what the total logged mileage was from his first voyage, as I could mostly only find many different comments of the 60,000 miles that were logged during his second voyage, but I could only find one mention of the estimated mileage for his first voyage, which was based on a Google Earth route tracing and based off what I already know about the GPS meridian distance corrections that are built into the GPS coordinate system. From what I had explained in my previous globe race video, and how Google Maps and Google Earth use these meridian distance corrections that are built into the GPS, I knew that I could not trust this Google Earth estimate, nor can I trust any GPS distances ever again, especially southern distances below the equator, which is where this first voyage was primarily navigated. So I knew I had to do some further research on this first voyage to get a more accurate idea of how many miles were actually logged in this expedition. As tedious of a task as it was, I went through the several hundreds daily mileage entries and added up the total mileage logged for each day that was written in Captain Cook's first voyage journal, and after adding up hundreds of pages worth of mileage entries, as I somewhat expected, the total miles navigated came out to quite a bit more than the estimated Google Earth distance. The total mileage logged for this first voyage from my added calculations came out to about 41,327 miles, over 11,000 miles more than what Google Earth estimated, which is an interesting number. For a few reasons, it's a pretty similar mileage compared to the Golden Globe race distance that I had calculated at about 43,680 miles, the one globe race that doesn't use GPS nor GPS meridian distance corrections. Now, if we compare both of these routes side by side first on a standard Mercator projection, we can see how close to the same routes they took. And furthermore, you will also notice that Captain Cook took essentially the same route, but at many times on a much lower 10 to 20 degrees south latitude track throughout most of the voyage that was closer to the equator than the route the Golden Globe race would take. Notice how Captain Cook travels above Australia and the Indonesian islands rather than below them as the Golden Globe race route takes. If we were to hypothetically bump this Captain Cook first voyage route out to the same 4250 degree southern latitude route as the globe race, it would be navigating closer to around the 43 to 45,000 mile route that the Golden Globe race navigates, which only makes the first voyage total logged mileage make even more sense. Now let's look at this first voyage route on a flat-azimuthal equidistant flat map and compare it to that of the Golden Globe race on a flat Gleason's map, and it only becomes more apparent how similar and almost nearly identical their circumnavigation routes actually are, and only further validates how similar their total calculated mileage is nearly the same relative to their latitudes they navigated on. How is it that Captain Cook's first voyage that was so closely navigated to the equator for a large duration of the expedition, coming out to a total of over 41,000 miles, when the circumference of the Earth's equator is allegedly only around 25,000 miles? The math just simply does not work on the parameters of the globe model and only adds more mathematical impossibilities.
Cook's, yeah, there we go. Captain Cook's Curious Time Capsule. Well, as I've said before, Captain Cook left out Summer's Gate. After his second book didn't come out for 6 years, Captain Cook never saw his his second journey book come out. Because he left for voyage number 3. I think he went out Summer's Gate, and they had to make up a lie because they realized he was fucking gone. So they're like, let's say that the Hawaiians ate him. Well, how would they know if they ate him? Let's say that the Hawaiians ate all of them except for his hand, and then they gave the hand back to the crew, and the crew's like, it's definitely him. Look at his hand. Oh, it's his hand. He's definitely been eaten by the Indians or by the Hawaiians. It's so fucking stupid. The whole story is stupid. I get upset that anybody would believe the most ridiculous story that Captain Cook. First of all, Captain Cook couldn't swim. Makes sense. Yeah. Huge boat captain. I'm not going to swim. I'm not going to swim. Real tough to swim. So he didn't know how to swim. And all of his men were being attacked or something. So what did he do? He just got off the boat and said, I'm going to go walk over there and deal with these guys myself. And he walked into a crowd of Hawaiians, and then they all ate him. Ate him right there on the beach while people watched. And then they turned his hand over to the crew, and the crew's like, it's definitely him. Look at his hand. He's dead. He's dead now. But if you went through it, I mean, I have to go through all this stuff. If anybody's looking to research, go through these books, find things, or these guides, because you'll find things that we didn't even know. That will, I mean, nobody knows these things, I'm sure. All these discrepancies in Cook's books, I wouldn't know. Let's see what we got here. Notes. It is on the first day, and there are already complications aplenty. It is unclear from the two diaries when Dawkin, Cook, and Barrell started from their boat. B.A. says that on September 9th, Dr. Cook and I started alone for the purpose of exploring Mount McKinley. On September 9th, Dr. Cook and I started alone. Mount McKinley. Barrell's map says that they left the boat the morning of the 8th, but since Dawkin is said to have turned back after the second day out, that would seem to imply that they left on the 7th. But at its end, BA says Dawkin turned back on September 10th. CD 47, page 47, implies two previous traveling camps, see below, but this might be corrupt because Cook apparently set back his dates. And so this might be the description of the later day than the date given. Cook writes on page 43, on the 6th day we pulled into Tokishita and their brill make a dock for the Bolshoi. John baked the bread, and on the next day, September 9th, we started for the GL. Cook left with Dawkin and Barrell in his motorboat on August 31st, so the 6th day out with the launch would be September 5th. So the next day could not be September 9th. However, Cook definitely sets September 8th as the first day of the climb. So we will observe this convention throughout. Notice that there are two completely different versions of September 8th on two completely different pages. So, I mean, this is the kind of bullshit that they'll never tell you. So at least somebody's looking into these things and calling out science for being a fraud. Okay, all those books are rewritten. Captain Cook's logs were rewritten by the Queen. He turned in his logbooks to the Queen, and it was 5 or 6 years until they were published. He was already gone. He was already dead by the time his second book was published. So they could have changed anything. And what they did is they probably took, I mean, have you ever seen his path, the Captain Cook second journey? Cook second journey path. Because he went 60,000 miles, so they don't want to show that. I mean, what do you do that for? So instead, he just went like this all over. Just circling and doing, because it has to be 60,000 miles. So it's just the path is just nonsense all over the place, doing a bunch of ducking and diving and ups and downs. Yeah, I'm sure. It doesn't even look like 60,000 either. They probably got it wrong. It's a better one here. Yeah, just kind of go all around. And when you go up here, do some circles. But again, that wouldn't even be 60,000. And that's what he says. Captain Cook's logs say 60,000 miles. And he keeps saying, and all we could see is ice to the farthest, to the east and to the west that we could see. Okay. So where did he go on his third journey? Out the gate. So I'm out of here. These guys are cheating. It's probably right here. Here it is. Got the gate. Come on the other side. And he would have taken a bunch of money with him, and he would have taken everything he needed and just left. Or you could believe that he was eaten by the Hawaiians because they were fighting, and then he came on shore, and they're like, that's it. Let's eat their captain. All these other guys that we've been fighting, let's eat him. And what happened is, like, he was going to shoot them, but his gun jammed. Now, he only had, like, one of those little pistols that they had back in the 1800s, so how would he have attacked the thousands of Hawaiians that were there? You don't understand things like I do. It's definitely... Oh, let's see. Second journey is the green. I did some circles over here. I mean, these are, by the way, scientific. Don't question it. This one here, very scientific. It's right here. It says enchanted learning. So why doesn't it match these other ones? Well, the other ones didn't have time to look closely. Captain Cook's second voyage was from 71 to 76. He sailed to Antarctica, explored the Easter Islands, and he was the first person to cross the Arctic Circle. He explored further than any European had explored. Are we going to mention the fact that he did circles out here? I mean, this is not 60,000 miles, first of all. I want to verify this. Is this really what they say is second? This is not even close. What do we got here? Oh, I can buy this? How do I buy it? I need to buy this. The fuck would buy this? Okay. How could that be 60,000 miles? You gotta be kidding me. Who believes this? Wasn't it? There we go. Cook's second journey distance. They don't mention it here, which tells you something, right? Second voyage of Cook, 72 to 75, commissioned by the British government. Right, but flat earthers, why don't you have a map yet? Huh? We had Captain Cook who went out with the millions of dollars from the British government. Why don't you have a map yet, Flurfs? We had one easily. We just sent out entire crew. We sent out armies of 500 people and we did it. Why can't you guys do it? If you're gonna claim that you have a model, you have to have a perfect model like we did that we spent millions and billions of dollars on lying with. Of course. Can we get to? Okay. Mm-hmm. Of course, he visited all these places, right, on his voyage. Do we not going to say how far it was? They might hide it down here. They don't want to put it too high up there. They're not going to want people to see that because it's... Come on, let me put miles in here. Let's see if we can find where it's at. Miles. Okay. Cook continued to explore Antarctica, heading south into the summer sea ice, icebergs, and fog until he reached 6731, before hauling north again for 1,400 miles. The third crossing of Antarctic was the precursor to the most southerly penetration. Gotta love that word. Reaching latitude 71, longitude 106 on January 30th. When they could go no further, it was because of the solid sea ice, and on this occasion Cook wrote, I who have ambition not only to go further than anyone had been before, but as far as possible for man to go, was not sorry in meeting with this interruption. They don't write actually the Great Line, which is the east and west wall of ice. What do you mean there's no ice wall, you stupid idiots? Yeah, no ice wall at all. Okay, where else? That's it? That's the only word miles in the whole thing? Okay, they're just hiding it. So stupid. Why wouldn't you just tell us how long his journey was? Not anywhere? No. Okay, we'll find it somewhere else. Pretty sure it's going to say 60,000. Captain Cook's second voyage. Okay, let's check this one. Control find. Miles. Oh, 150. No, I'm just kidding. They were not particularly fast ships. Daily runs of 150 miles were usual, and anything over 100 was considered good. After 109 days at sea, they reached the Cape of Good Hope. Okay, that's not there. Let's go somewhere else. Came within 75 miles. Okay, and having sailed 11,000 miles. Okay, no, not going to tell us here either. Wow. Can we put distance up here? Did we put that? Captain Cook's second journey. Total distance. I don't know. That's not telling me. Well, I know why they're going to tell me, but second voyage. That's not going to help us. Second voyage. They really don't want to say, do they? Here we go. Oh, some sources? No, that's... oh, of course, it's a flat Earth thing. It's always, by looking carefully at James Cook's... Now look at this one. All of it, we can easily find the distance of 60,000 miles is reasonable and does not... Here we go. I mean, typical freaking Globers. Look what they do. Like, by looking... This is what they looked at this and said, by looking carefully at James Cook's route of his second voyage, we can easily find the distance of 60,000 miles. And it's reasonable and does not require an extraordinary explanation. Because he did this, of course. I mean, it's easy. So he could have gone 275,000 miles. And these guys would draw yellow lines all over this map and be like, look, the second journey, we can easily see where he could easily get 225,000 miles. So it's reasonable and does not require an extraordinary explanation. Okay, they just darted in and out, darted in and out, darted in and out just so we can get up that high. Now again, what happened is that they did this after the fact. It's post hoc. So he got back 60,000 miles. We did this. He was gone for this long. They're like, okay, we have to keep that the same, but we can't say that he went around the outside. So we'll go up and down, up and down, up and down. And then we'll just say that. Okay. Second voyage of Cook was Flat Earth WS. You know, this guy just lies in all his little graphics, and everybody just uses them like, oh, this has got to be true. But you got to stop telling me this is 60,000 miles. Let's do it. Let's bring up the fucking Google Earth and draw this just so I can see. I got to know for myself. Can't just believe people anymore. Where is the freaking start? Oh my god, I'm losing my mind. Thank you. Stupid. I hate this now. How do I find things? Google Earth? Why don't you just have the start menu? What was wrong with the start menu? What was wrong with it? Anybody ever open the start menu on Windows 10 and be like, I hate the start menu. It has all my programs listed exactly where I want them. Oh boy. All right, so let's see if we can get this over here. And we're going to draw that same line here and see if we get the same thing. So then we know, because if it does do the same thing, well, then clearly you don't have any reason to look into it anymore. Okay, let's go down here. We're going to start over. It doesn't really show where we started. But we would say that we started up here. All right, let's come down. Looks like we go this way. We're going to grab this button. We're going to use the path. And they start about here. Okay, we're going to come down. We're skirting by here, going around here, and ducking under here. Then we're going to go to here for some reason. Because this makes a lot of sense. He like came out here and said, now let's go this way. Right, makes sense. Then they said, now... what? How does this even connect over here? Okay, good luck figuring this out. Wait, this arrow's going this way, so they came back this way. So where did this arrow go? Oh, it comes out over here. Okay, so he goes over, and so we are in Africa here, going past it, then down. So maybe here. Now they go down here, and then here. And then, you know, this made a lot of sense. They were like, let's go up here and come back down. Right? Days of a trip there. That would have been like 3 days up and 3 days back. Makes sense. And then they go down here below Australia. See that? And then here. Okay. Then they go here. And let's see here. So New Zealand, they go kind of up and around here, kind of as high as Australia. Okay, so up, around here. And then said, let's go back because we think we went the wrong way. Let's just circumnavigate New Zealand for no reason. Makes a lot of sense, though. Come here. Let's go down here. Okay. And then we go. Where are we at? Oopsie. Didn't mean to do that. This one should be down here. All right. So we come around New Zealand. Then we go down here. Then we went up here. Then down here. Then up. Oh, we're already by South America. So this is kind of a little bit longer. Like that. Like that. And then we go up here. For some reason. Oops, that's all one. This one here. This one here. Go up. And then back over. Right. Makes sense. Right. You want to go up here. And then back over here. Just double up. Let's do it again. Yeah, let's do it again. Definitely did that. And then come here. We're just going to go on the same path we already went. Because we kind of know the way, right? And cut here, cut across, go under the south. Oops, here, go here. It's a good route so far. And then they go, I don't know what this is showing, somewhere like this, and like this, and like this, and back home. Okay, well, that's 53,000. So that's, I mean, there's no reason to look into this further because clearly just you can see what we can make it do easily just by putting a couple more dots in there. Move this one over here. Maybe they went over here for a little bit. Can't contrive this either. It's definitely fact because clearly they've never lied to anybody. And so just to assume that they would lie about this, that's stupid. Like maybe he went here and then went here and then they thought to go here and then went here and then here and then here and here, and then here. There's 60,000, right? So clearly, that makes sense. Clearly, that's how people sail the oceans. They just went every direction a couple times. And, the doubling back is always smart. Always got to double back in case you miss something. Well, not always, only something, half the time. Half the time you double back. So I'm a believer now. Thank you for Reddit fix that for us, if you think about it. Now, can we at least...
One thing not many people know about is NASA named some of their space shuttles after Captain Cook's ships. Cook explored and mapped more territory than any navigator of his era, and his achievements later saw him honored by NASA. So his ship Discovery was one of several historical vessels that inspired the name of the third space shuttle, and NASA later named their final shuttle Endurance, which of course was named after one of Captain Cook's ships as well. But let's talk about his journeys. It really his first and second journey, but we'll also cover his third journey a little later. Here's a picture of one of his ships. These are the type of ships that he used when he was exploring. And here is a map of his first journey. The journey's always begun here. Came around, took a break down here, and restocked for supplies by Cape Horn. Now, this is his first journey. So, he left home, he went to Cape Horn, and then he kind of was out to sea right here. What they was looking for is something that at that time they called the Great Southern Continent. At that time they believed the Northern Hemisphere had all this land up here, so they believed that there was a huge continent in the Southern Hemisphere also, something that laid undiscovered. So on his first journey he came here and he was searching for that continent, and he discovered New Zealand, which he did claim for the crown at that time. Then when he left the area of New Zealand, he discovered Australia, and he went up the coastline of Australia here, where he ran into trouble and hit one of those barrier reefs and knocked a hole in the ship, and he had to pull on shore of Australia and repair the ship. Now this was the only time that happened to Captain Cook, where he had to dock his ship in such a manner. And then he later went on here to the islands, and he came down to South Africa, and he floated on back home. A journey this size took him 3 years. It was from 1768 to 1771. Ironically, when he left for his journey, the first journey, his wife gave birth and the baby later died while he was out to sea, and he had no knowledge of this until he returned home. Now let's take a look at this same journey, but on a flat earth map. Now here is Captain James Cook's first voyage, but done on a flat earth map. I've done the best that I could with the tools that I have in marking it out. So he left his journey and went to the bottom by Cape Horn and restocked for supplies. Then he went on out into the Southern Hemisphere oceans, searching for the great continent that was believed to be in here. And he actually later came out and said there is no great southern continent. Then he discovered New Zealand, and he mapped it out. He was a great map maker, and he came around New Zealand and up the coast of Australia, where his ship got damaged and he had to fix it there, and back around to the bottom of South Africa, where he restocked again and came on back home. 3 years. And as you can see from this map, he was circumnavigating the ice rim. But his second mission, he even came closer to the ice. We're going to get into that right now. When he arrived home, it was 1771. He basically stayed home for a year before he decided to go back out to sea and start his second mission, which is now on the screen. Again, he was searching for the great southern continent. He left home, and this time, instead of going to South America, he went to South Africa first. After leaving South Africa, he went further south, and he was experiencing a lot of ice and a lot of bad and cold weather. And this mission started in 1772. He only stayed 1 year at home. He cruised around the ice rim here, and he went back to New Zealand, a spot that he now claimed for the Queen, and he restocked. And after he restocked, again, he was doing his searching. Restocked. Search. Restock. Finally, with no luck of finding this continent, he started his journey, went to Cape Horn of Plenty, they called it. Then he went on back home. And this mission, like his last mission, lasted 3 years. So when he got back home, it was now 1775. These guys didn't mind going out to sea for many years, not knowing if they would ever come back. They were truly explorers of their day, and that's why they are remembered to this day. But they also are remembered because of the land they claimed for the Queen. New Zealand in this case, and Australia. And into this day, this land is still recognized and owned by the Queen. I'm going to get to that in a minute. I'm going to show y'all what I'm talking about. But anyway, let's take a look at this map, but on a flat earth map. Okay, here's his journey mapped out on a flat earth map, where he leaves his home, goes to South Africa, comes around South Africa and he's riding the ice rim right here this whole time. Goes to New Zealand and restock. He explores around this area here, which he never finds the great continent that they were looking for, because there is no great continent. There is an ice rim. And he actually came clean and said that there was no great southern continent. There was an ice rim. Then he restocks in New Zealand, rides the ice rim again, heads on back to the Horn of Plenty, Cape Horn, restocks, comes back home. 3 years journey. 3 years it took him to go around this ice rim at that time, back in the 1700s. So I find it quite amazing. And this is good evidence that the earth is flat by him never reaching this continent. And they did see, they seen penguins and, you know, they seen all kind of ice, but they just never really came clean or admitted that there was a continent. And he was a great map maker. He would have seen something like that, and he would have, if there was a continent down there, he would have mapped that continent out in a heartbeat and claimed it for the Queen. That was his job, and he was very thorough at doing his job. He wasn't just a run-of-the-mill captain. He was a great captain and a great map maker. One of the best of all time. Some of the maps that he mapped out is still used to this day. For example, the New Zealand map. They still use his mapping when they're showing pictures of New Zealand. Now here's a great example of Captain Cook's map making I'm going to leave a link to this video in the description box because it was really a great documentary. Now this is what they had gave him, the map they gave him of New Zealand.
He started charting the territory.
As you can see,
Compare it with the satellite image, it still doesn't match up.
it doesn't, right. That's his map right here.
Okay, here's what Cook produced 5 years later. Now this really is a map. Just look at this detail.
See the detail? He would have easily mapped Antarctica.
And when you put it up against a modern satellite image, you can see just how precise it is. So precise, in fact, it was still being used well.
It's probably still being used today because satellites, in my opinion, don't exist. It was just a little off right here, but who knows, maybe throughout the years something got messed up in this area. Something got messed up on his map. Maybe they didn't want it to add up perfectly. But I think Captain Cook, I think his map was pretty close to perfect for mapping this area. He was a great captain and a great map maker. Okay, now to this day, who governs New Zealand and who owns it? I know they feel like it's the people own it, or they have their own government, but in reality, the Queen owns it. Queen Elizabeth II is the country's head of state and is represented by a Governor General. Okay? Queen Elizabeth this day is ruler of New Zealand. Maybe ruler might not be the right word, but I promise you any kind of diamonds or gold or riches found in New Zealand, that's going to go to the crown. Sure, the people who's mining it might get some of it, but the bulk of it's going to go to her and her family, of course. And it's the same thing with Australia. She's a ruler of Australia, and all the riches of that country will go to her as well. So let's see. When the Queen visits Australia, she speaks and acts as the Queen of Australia and not as Queen of the United Kingdom. And I assure you, if Captain Cook had discovered a continent in the southern hemisphere, like the continent that we are believed or led to believe exists, called Antarctica, the Queen would own that continent. The only reason why they don't own America is because we had a revolutionary war against them at that time. But I assure you, if that continent did exist, it would be owned by the Queen. But the continent does not exist. It's an ice rim. And Captain Cook proved that. He proved it without even knowing it. Here are some of the details of his second voyage. And right here in the agenda, it was to search for the southern continent in the Pacific, and he searched for it, yet he did not find it. Why did he not find a southern continent is the question. I'm going to leave a link to this site as well, because it's very interesting and it's a great read. So in closing, I'm going to say that Captain Cook was a great explorer, and had he discovered, if there was an Antarctic, a continent below, he would have claimed it for the crown. That was his job, and he would have been very proud to do his job. Hey guys, I have this book here. It's with Captain James Cook in the Atlantic and the Pacific. The Private Notes of James Burney. And he was the second lieutenant on the Adventure. And this was Captain Cook's second voyage, from 1772 to 1773. He was on the other ship, so to speak, and he was under Captain Tobias Furness. The book has some great art type work, and this artwork was done by an artist on Captain Cook's ship, and the artist's name was William Hodges. This is one painting by Hodges. And the book was published in 1975 by the National Library of Australia. It has some very interesting stuff about their journeys, in my opinion, around the ice rim. It also has some more artwork and illustrations in it. And it has this nice map here. And the map shows both of them, both ships, on journeys, and where they got separated. They got separated here. As you can see, though, this would be like the ice rim down at the bottom. When they got separated, Captain Cook went further down, further south by the Antarctic ice rim here, where the other ship, the Adventure, they went on to New Zealand. And this guy was on that ship there, James Burney. So him and his captain and their crew, they didn't dip down as far as Captain Cook did, but they did dip down right here. They were together, both ships were together for this part of the journey. And when they got to New Zealand and Australia, they went back together. And that's where Burney and his crew, they went back. They went back to England. And Captain Cook and his crew, they stayed around this area and dipped down further, looking for a elusive continent that they never found. And it still hasn't been found. It's the ice rim that they found, or that they circumnavigated. Also, I wanted to add that the book is on a more of an expensive side. It can range from about 100 US dollars to around 700 US dollars. And if you're living in the US, it takes quite some time to get it to you, simply because it's either going to be coming out of the UK or Australia. But this is a great way to do research, because you know that this book's been around since 1975 and it hasn't been really messed with. And it's also a first edition, first published in 1975, copyright 75. It has been kept in great shape also. It's the only thing that I found actually wrong with it was on the jacket itself. It had a little rip right here, but other than that, it's a beautiful book, and it's a piece of history right here. So the notes in here that this guy wrote are from his personal journal, and we know that this book hasn't been touched since 75, since this book was published in 75. So we're going to just take a look at it. Anyway, I'm going to read y'all a few passages out of this book, mainly the parts where they were by the ice rim. So I hope you enjoy it. Okay, this is a reading from James Burney's private journal, dated 1772. And we're going to start the reading off in December of 1772. And it was December the 10th. This morning we fell on with an island of ice, which at first we mistook for land. In the afternoon we saw another and 2 penguins, birds which are said never to be far from land. We tried sounding, but got no ground. At this we passed great queries of ice every day, the weather very cold. Through near midsummer at this point of the world, the quicksilver in the temperature kept constantly between 27.5 and 32. The islands we met with at sea is disintegrating by 2 different names, islands and fields, though in fact they are all islands. The fields of ice are low and level and are many in length. We have sailed close by one above 6 lengths without being able to get past through or seeing the end of it. The islands are very high, rigid pieces, seldom more than half a mile in length, and are about 150 feet high from the surface of the water. There are some of the largest islands, at least as high as St. Paul's. I only saw 2 in this enormous height. One of them, I am certain, was much higher. The islands seem to change color as the weather changes. When the sun shines and the sky is clear, they are of a fine light blue and transparent. In bad, dirty weather, they resemble land covered with snow, the lower part appearing black. If a ship should run against a large piece of ice, I make no doubt but she would receive as much damage as from a rock. Okay, the next reading is from January the 12th, 1773. This day we again hoisted our boats out and got ice until it filled all our empty caskets, having more water than when we left the Cape of Good Hope. We were now in 64 degrees south latitude, weather better and warmer than before, the seasons being more advanced. Okay folks, so basically on Monday, February the 8th, 1773, the Resolution and the Adventurer got separated. It was foggy, and they fired weapons into the air and did not know which way the sound was going, and that probably just made matters worse. So they parted ways and headed to a New Highland, which of course is Australia, and that was their meeting point there by New Zealand. And this reading is from Captain Tobias. It's just like a side note. I guess the author of this book added it in here, and it says Tobias had begun to doubt if there was any such place, and they're referring to any such place like the land of Antarctica. If there was, it must be some spot not hospitable by reasons of the intense cold. And also Captain Cook had previously concluded that there was no land in the area, nothing but mountains of ice surrounded by ice fields. He was only sorry that in searching after this land he had spent so much time, which will become more valuable as the seasons advanced. Okay folks, so there you have it. They was stuck in ice, running around this ice wall, searching for a continent that didn't exist. They got lost, separated from each other, and could have very well died. But these are old first accounts of the Antarctic ice wall. Okay guys, I just want to do a little recap of what I've just read, and especially the part about March 12th, when it was in complete darkness and a massive iceberg was looming directly ahead of them. In the reading it said March 12th, and the year was 1842. It was in complete darkness. Yet if you go here to timeanddate.com, you can look up what kind of daylight there was during this time. Just go to this, scroll down. I'm going to leave a link in the description box to this. There's a little drop down box. You may have to mess with it a little bit. See, once you get to a certain point, you're going to have to keep scrolling. Go to that. then you'll have to continually go. I'm going to leave a link to it, so hopefully the link works and it'll take you directly to this year that I'm talking about, 1842. It was 24-hour sunlight, and they should not have been in complete darkness if there's a 24-hour sunlight in Antarctic. In fact, the sunlight stays 24 hours all the way up to the 21st of March, and it was there on March the 12th. So I hope that answers a few questions for you all. It should also be noted that they have here a warning: local time history for years before 1970 is not available for the South Pole. Instead, local time for McMurdo is used for the years before 1970. So we will be going by McMurdo's time, which of course is right here. Here's the coast of New Zealand. Here's McMurdo. It's a little island by Antarctica. And that was 24-hour daylight here in 1842. So there should have been 24-hour daylight all across here. All across where Ross and them was exploring. And there obviously wasn't, because the reading obviously said they almost hit an iceberg in total darkness. Alright guys, back to the readings. Ross departed the Franklins on December 17, 1842 for his third and final season in Antarctica. His desire was to penetrate the Weddell Sea and add to the research done by Weddell in 1822. Unfortunately, he met with dense, impenetrable ice pack and icebergs. Abandoning his plan, Ross crossed the Arctic Circle on March the 5th, 1843, and the Terror sailed for home. Ross wrote, "The shores of Old England came into view at 5:20 a.m. on the 2nd of September, and we anchored off Folkestone at midnight on the 4th. The voyage was complete after 4 years and 5 months at sea."
This is the, just so you know, we're going to be talking about boats here real quick, because planes, I think, can get up faster than we think. And also, I showed articles on my show the other day. There's already been articles that such and such plane has broke the sound barrier, because with the winds aloft, and that's just in the north, when the south is many times faster. But in the north, planes will catch that stream and they'll get places a lot faster, and they'll break records. And then there ends up that their miles per hour was 950 or 970. But that's because they were going under the Mach and then Mach 1, and then they get the wind with them. So, but boats cannot really, as far as I know, aren't going to move a lot faster than we think, right? Like a cruise ship that goes 22 miles per hour is not going to bust out and do 40. You know, it's just, I don't think it's possible. So when you look at boats, let's start with this Antarctic Cup race, right? Which is what people always send me to. This is the cup race that they have once a year. They show the path of the races here. So basically they will race around this track. They don't go below the 60-degree marker. They race around this, and then there's a world record. And the current world record you'll see here is 102 days, 56 minutes, 50 seconds, okay? So remember that they sail the entire time. They don't take naps. They don't, you know, as far as like somebody will sleep, somebody will sail, but not, they're always moving. So at 102 days, we'll do a 102 times, let me get this up. We'll keep track here. So 102 times 24 hours equals 2448. That's the amount of hours that this thing was traveling. And it did a circumference of 16,000, where does it say the miles? I think it's 16,000 miles. I don't see it right off here. It's a nonstop race around 14,000 nautical miles. I don't see it right. It should be about 16,000. Let's just say it's 16,000 and we'll come back. But 2448, so that's the hour. So we're going to go 16,000 divided by 2448. And we get 6.53 miles per hour, okay? So that's how fast he was averaging to get around 16,000 miles in 2,448 hours. Okay, great. Now let's look at what the circumpolar current is. Okay, it's the biggest current in the world. It is the fastest moving current. Here you go. The Antarctic circumpolar current flows clockwise. Okay, which is the way the race goes, which is the way people circumnavigate the world. You have a hard time doing it the other way. And when I say circumnavigate, I mean on the outside track, obviously. And it talks about it goes west to east around Antarctica. Anyway, when you look into it deeper, you can figure out that the average speed is about 2.5 miles per hour, sometimes 3. So we can now take that 6.53 miles per hour that we said the guy was averaging, and we can minus from that 2.5 because that's the current speed. So he's moving without even moving 2.5 miles per hour. Therefore, his boat is only actually going 4 miles per hour around the world. Okay, so now we find out who this guy is, and he races let's find his name here, I think. He races his 85-foot open monohull trading boat. So I go search and find the fastest 85-foot monohull, and you find out that the boat goes 36 knots. That's 41 miles per hour. Wow. So a boat that goes 41 miles per hour has the world record for circumnavigating the ocean while traveling 4 miles per hour. Okay, so if you believe that, that's fine. But that's what happens when you're lying to people about distance. The guy probably got back, and if you asked him, for all he knows, he was going 4 miles per hour because he traveled 16,000 miles and it took him X amount of time. That's what speed is.
Well, he probably just divided the math, and he divided the time into the distance and said, "Wow, I thought I was going a lot faster than that, but it only says 4 miles per hour."
Right. I'd love to talk because I bet you would say something like that. So, and then all of a sudden you realize there's not a lot of difference you have to do. So if instead we know that there's 2,448, well, let's say some people have said that the circumference is 60,000. I don't know. I don't know if things are that big down there. Maybe 50,000, but let's just say 50,000. Just to see what speed would somebody have to go to complete that. And he's not all the way at the edge, remember? So the edge would be 50,000. He's not even past the 60 degree. He's just doing a circle at about the 60 degree mark. So let's say it's 50,000.
Yeah, they're usually in like the mid 50s.
Yes.
Or thereabouts.
We'll go one more time and look at where was the boat? Here we go. So you'll see that they're not even getting, this is the 60 degree line here, this white line. And so they're staying above that. So right below Australia, they do have to duck down, obviously, in South America. Anyway, so it's not even the outer edge. So let's say it's 50,000. So we've got 50,000 divided by the 2,448, and that comes out to 20. So even at that, the boat's only going half the speed that it's capable of. That seems to make more sense to me than a boat that maxes out at 40, breaking a world record going 4. It's just ridiculous. It's like a car breaking the world record for the fastest trip around a track, and it actually goes 400 miles per hour, but it only went 4. What are you talking about? Why would it do that? Wouldn't somebody just come and break the record easily by going 8 miles per hour? Same thing is true with these boats.
Doubt.
Why isn't somebody breaking the 102-day record by going and, I don't know, putting your foot on the gas pedal at the boat? You might move a little faster than 4 miles per hour. And so that just tells me that this area here is much more vast, and nobody would ever know. It would be impossible for a sailor to know because they're going to base everything off of known land distances, and those, when I say known, it's what GPS gives you. GPS gives you these answers. So when you figure out that, that boat fastest goes 41 miles per hour, and yet this guy's breaking the record going 4, it's that to me is a big problem. And then the other thing,
the Antarctic sailboat race, which they have every couple of years, they don't even
actually have that written down.
Yeah, they don't go near Antarctica. They can't even see Antarctica. They're like 50 degrees south, 40 degrees south at some points. And even on their website, the last time they did it, there's one leg of the race from Africa around Antarctica and then over to South America. That leg, which is a big leg, was 32,000 miles, according to the race. Wait a minute. The equator is just 25,000 miles. How did just going around that little 13,000 mile continent turn out to be 32,000 miles? And then they had another 10,000 miles to go to finish the race. How are they going around Antarctica and making a circle bigger than the equator? Weird? Can I get a weird?
Can you explain that one in a different way? I wasn't able to follow that.
So if you look at Antarctica on a globe, it's a continent at the bottom of the globe. It's kind of a circular continent, and they tell us it's about 10 to 13,000 miles in circumference. So if you wanted to sail around it, you would go about 13,000 miles.
Okay.
So the Antarctic sailboat race, you've seen those sailboats. They're the most high-tech sailboats in the world. They're amazing, right? These are the fastest sailboats in the world. And they're saying that the one leg of the race, which is like 2/3 of the race, was 32,000 miles. You got to remember the equator, which is the biggest circle you can put on a globe, is only 24,900 miles. So how did that one leg become 32,000 miles? The other thing is, when you're out in the ocean, you don't know how far you're going. Because if you're not over land, you don't know how far you're going. The only way to be told your distance is a GPS, pretty much, right? And GPS is run by NASA. And so when they look at it, they say, okay, the trip took us 30 days, or whatever it was. I forget it was 30 days, 60 days, whatever the amount of time it was. And they say, okay, well, at 50 degrees south, the race should have been like 18,000 miles or 20,000 miles, whatever it was. So they take the time divided by the distance, and they say, well, the average speed was 3 to 4 miles per hour. 3 to 4 miles per hour. Now, are those boats go? Those boats can go 3 to 4,000 miles an hour when they're tied up at the dock, right? 3 to 4. The reason it's coming out like that is because they're traveling a much bigger distance than they're being told. And so we had at least one of those sailboat captains has come on our shows saying, I know how they're faking it. The earth is flat. We're sailing much greater distances. They're using magnetic declination to hide the flat earth because there is no magnetic declination on the flat earth. It's only on the globe that you have magnetic declination. Go ahead. Sorry. I'm talking a lot. So you guys ask.
No, totally fine. And that was going to be my next question is, are these people that are taking part in this race, are they being lied to or are they lying?
No,
that was my big question.
They're not even being lied to. They're being lied to by GPS, the ground positioning system. But some of them are figuring out. Other people are like, oh, well, I guess there was a big current. I guess, these guys are going, the boats are going 20, 30 miles an hour at times. But the average speed is 3 to 4 miles per hour if you take the time and the distance that they've traveled.
The distance.
Yeah.
Okay.
And it's hard for them to figure it out because they're like, well, we're at 60 degrees south, now we're at 40 degrees south, and we're here. These guys, when they're done, they're sailors. Okay, they're not there doing math. They're there, sailing as fast as they can. And I don't know why they all don't speak out when they hear that they only were going 3 or 4 miles per hour. They should all know. But it's willful ignorance, if they don't. But a couple of them have spoken out, and
circumnavigation is easily proven to have been done on a flat Earth. Let's look at over 20 claims here, starting with the first one. It's Ellen MacArthur in 2001. She finished second on a yacht race, and as you can see here on the map, it can easily be done on the flat Earth map, either from east to west or from west to east. Right, not ever over the poles. Okay, the next one that we are going to be looking at is Mike Golding. Mike Golding is a Englishman. He's from England, and he same thing as Ellen MacArthur, same route around the flat Earth. You can see how easily it can be explained with the flat Earth map. The next one, Tony Gooch from 2002-2003. He circumnavigated from Victoria, Canada to Victoria, Canada. Okay, easily explained on the flat Earth map, as you can see on the screen. Next one that we're going to be looking at is the first deaf person to circumnavigate solo in 2004. He went through the Panama Canal, not even around South America, but it can easily be explained on the flat Earth map, as you see here on the screen. The next one, Bruno Peyron. I believe he's French. He's a French yachtsman, and he circumnavigated just like Ellen MacArthur and the other guy in the beginning, easily explained on the flat Earth map. Easily, you can see there the easy map. That's how he did it. All right, let's look at the next one. Denise D. Kafari, okay, in 2006. First woman to sail single-handedly and non-stop around the flat Earth the wrong way. I believe she started from west to east, but same way that the other people did. Okay, nothing new there. The next one, we'll look at the Queen Mary 2. It's a cruiser, a boat, okay, a ship. It's circumnavigated around the flat Earth. You can see on the map exactly the route. Never over the poles, of course, because it cannot be done either by sea or by flying or, walking. There's no way. Nobody can circumnavigate the South Pole, over the South Pole. The next one is the Earth race. It's now known as the Mai Adigil. That was in 2008. You can see there they circumnavigated through the Panama Canal and the Canal of Suez in Egypt. So they didn't even go around South America or Africa or Australia. Right? So there's not even a circumnavigation considered that. Well, it is, but not over the poles. The next one, Francis Joyon. Where is he from? French. Okay, he's from France. And sailboat racer and yachtsman. 2008, he circumnavigated around the flat Earth, just like most of them do, around South America, Africa, and Australia, but never over the poles, of course. There's no way to circumnavigate over the South Pole. Michael Perham, another one, through the Panama Canal and around Africa and Australia, New Zealand, but, that's how they circumnavigate over the flat Earth. The Earth being flat, no way to circumnavigate all the way, either by plane or boat or any other way. Now, this guy, he circumnavigated around the Earth. He did more stops than the others. Let's look at Dilip Dondo. This guy, I don't know where he's from, but he is a commander to, his country. I don't know. Jessica Watson, she is from Australia. In 2010, pretty much like the others too, the way she did around the flat Earth. Next one, William Bride Stowe, an American artist and mariner. He circumnavigated pretty much like the others as well. Let's look at this girl. She's the youngest, 15 years old in 2012, Laura Decker. She's from New Zealand. And you can easily see how she's circumnavigated through the Panama Canal, not around South America. Planet Solar, I think this is the largest solar-powered boat in the world. Again, through Panama Canal, Canal de Suez, and in the north of Australia. Let's look at Maria Victor. I couldn't find anything about this lady. She's supposed to circumnavigate in 2013. I couldn't find any info about her. The next one, Gian Socrates. She completed her in September 2013? First female. She holds the records, oldest female to have circumnavigated. Next one, Abhilash Tomi. Abhilash Tomi from India. Okay, second Asian and 79 person to complete its solo circumnavigation. Gary Hughes. Gary Hughes is the first deaf man to solo circumnavigate the world, okay, in 2013. These are the people who have circumnavigated the world.
First, we're going to start with the Vendée Globe race. This race happens every 4 years and it starts out in France. This race navigates down through the Cape of Good Hope in Africa, then over to the Cape of Llewellyn in Australia, then over to Cape Horn of South America, and then finally back up to France to finish the race. Now, during this race, the participants follow a set of pre-coordinated GPS waypoints. That GPS waypoints generally guide them along their route during this race. Now we can also follow this race on a tracker. This tracker shows all the different race participants as they navigate this race in real time, and we can follow their route as they navigate around the world and sail back up to France and finish the race. Now we're going to go back for a second here to the GPS waypoints. These GPS waypoints they follow are called safety boundary waypoints. They are generally placed and located between the 40-degree and 55-degree latitude lines. They follow these safety boundary waypoints not just to guide them along the race, but it also keeps them from going down to the more dangerous turbulent waters below this 60th latitude line. They also prevent any of the sailors from ever actually seeing Antarctica and its vast coastline. Now these GPS safety boundary waypoints also have built-in meridian distance corrections to correct for the longer distances below the equator. And I will get more into those details later. For now, let's have around the world circumnavigation retired sailboat captain Hervé Raboni explain how they use these GPS safety boundary waypoints on these globe races. He will also explain how they manipulate these races through magnetic declination, boat speeds, and manipulating distances on GPS and Google Maps.
Of course, Hervé has figured out that the Earth is flat, and that makes him a friend. But what makes Hervé especially interesting is the fact that Hervé has actually sailed around the world. Not around a phony globe, but around our flat and stationary plane. Hervé was a participant in the 1993 through 94 Whitbread Round the World race. It is also called the Volvo Ocean Race. Here is Hervé listed as one of the participants. You can look it up for yourself. This is the boat he was on. It was called the Merit Cup. And here are some pictures of Hervé. This is a map of the race route, which began and ended at Southampton in southeast England. Based on his experience and his research, Hervé has some fascinating ideas as to how they have faked the globe, and some important information on what a true flat Earth map should look like. I hope that his information will lead to more investigation.
Now, as the map that Bob has up right now shows you were talking to me earlier about this, those little lines that are along the route, that those were requirements that you could not go below that. Is that correct?
Yeah, this is interesting, but it's not easy to explain. But it's the Vendée Globe. So maybe you know the Vendée Globe is there is no stop. The opposite of the Whitbread race. There is no stop there. You start in France and you go around the world, and the organization of the Vendée Globe put this mark here. It's a GPS point. There is nothing on the sea, but now with the instrument, you know exactly where is the boat on the map. Whatever is flatter of the globe, but you know where is the boat. So the boat cannot have to pass between. You see, there is two small points, okay. And the boats of the Vendée Globe have to pass between those 2 points. You see the 2 points here? Yeah, exactly.
Yep, on every single one. Yeah, so that's the boundary.
Okay, but that's very bizarre to do that, because it's for safety. It's to keep the boat away from the Antarctic because the ice it's dangerous, you know. So. The organizations do that. Like that, the boats stay away to the Antarctic. But it's strange because they can put only one mark and ask the boat to stay to keep the mark on starboard, on the right, okay? And like that, they can go also more on the north if they want, but with these 2 points, they are obliged to pass through these 2 points. The boats have less option, and there is less security too, because if you are in the north of this point and there is a big storm in your south, you're obliged to go to the storm and to pass between those 2 points. You understand me?
Yeah, that's crazy. So, and let me ask you something. Physically, I mean, how do you know you're within the boundaries of those 2 points? Because I mean, looking at them, they look like they're spaced really, really far apart. So, is there some physical marker, or is this like a GPS marker, or
No,
how is that done?
It's only GPS. But
Okay.
as I said, with the GPS now, you know exactly where is the boat, so the organization can know where are the boat and if they really pass between the 2 points. Okay.
Okay.
So that's bizarre because it's less option for the boat and it's less security for the boat. If they put only one mark and they ask the boats to stay in the north of they have to pass in the north of this point of this mark. It's really better for the course. You have also more options for the strategy to the option for the the forecast, meteorology, where is the wind, etc. But with these 2 points, all the boats have to go through these points, and it's not logic on a race boat. And I sent an email to the organization of the Vendée Globe to ask them that it's not logic to do that, and they never answer me. Because now maybe I think it's maybe because if a boat with the instrument that they are very specific now, if a boat is more in the north and another more in the south, and they can know now which kind of wind do you have, because there is very precise forecast map. Huh? So if you know exactly in the boat in the north of you have the same wind than you, and he goes faster than you. I mean, he gain more. I can say that. Yeah, he's getting faster to the arrival if he's in the north than if you are in the south, because on the flat earth it's the opposite than on the globe. You're going less distance if you are on the north than on the south. You understand me?
Absolutely. So you're saying in between the specific longitude lines, there's actually a greater distance that you're sailing when you're in the southern hemisphere than you are when you're in the northern hemisphere.
Yeah.
Okay, that makes sense.
So
And
they did stretch them out. They didn't. Okay, that's interesting for the GPS the way they did them there. I mean, and as opposed to skip over. That's interesting.
Next, we're going to talk about the Golden Globe race. This race is very much like the Vendée Globe race, as it also happens every 4 years, and this race also navigates almost the exact same identical route that the Vendée Globe race does. You can see it starting in France and going around the 3 main capes and then back up to France. However, this race takes much longer to complete, as the Golden Globe race takes about 260 days to complete. So, you can see that there's quite a big difference in the time duration of these races, as the Vendée race only takes about 90 days to complete. So this Golden Globe race takes almost 3 times longer to finish. The other main difference with this race is that it follows a different set of rules. The rules for this race follow the tradition of the 1968 Golden Globe race that was won by Sir Robin Knox Johnson. So their ethos is not using any modern-day technology on the boat during the entire race, which includes GPS. They also have to use pre-1988 sailing yachts, which move at a much slower speed than the racing yachts used in the Vendée. So now, we're going to take a look at the math for both of these races and compare. We can first look at the Vendée Globe race. We can see that it's 90 days with about 25,000 miles. It's navigated. With the IMOCA 60 yacht, with an average cruising speed of 15 knots, or 17 miles per hour. They also have a top speed of 35 knots per hour, which is an incredible sailing speed of 40 miles per hour. But for now, we're just going to go off the average cruising speed to get a base overall distance to reference to with the much greater mileage disparity of the Golden Globe race. Also, I will note that this average cruising speed is not reflecting the added for miles per hour boost and friction-free sailing of the Antarctica circumpolar current, which I will explain on more detail later. This average cruising speed of 17 miles per hour is only calculated with 14 to 20 miles per hour dependent winds, which are always consistent below the equator with the roaring 40s and the furious 50s winds. So for now, let's take the 17 miles per hour times 24 hours in a day, and we get about 414 miles per day. And then if we take this 414 miles per day average and times that by 90 days, we will have 37,281 miles. Now, this distance is quite a bit further than the official 25,000 mile distances that is listed. This distance is also only on the 40 to 50 degree latitude lines. Now, if we add in an extra 4 miles per hour and from the Antarctica currents, they would be traveling roughly 510 miles a day, and this would come out to about 45,900 miles. And again, this is not all the way out to the 60th parallel or anywhere near Antarctica, so this distance would be much greater. If you extended it out another 10 to 15 degrees latitude to the perimeter of the Antarctica coastline, so we can already see that the estimated overall distance navigated is not even close to the official narrative of these globe races, but the mileage disparities only get much worse. Now let's take a look at the math for the Golden Globe race. The Rustler 36 yacht, which is the most common yacht used on this race, has an average cruising speed of 6 knots or 7 miles per hour, with a top speed of 7 knots, so not much more than the cruising speed. But again, this is a pre-1988 sailing yacht, so it's not a high-end foiling racing yacht. If we do the math with the 7 miles per hour in a day, it comes out to 168 miles per day, and we multiply the 168 miles per day times 260 days, it comes out to a total of 43,680 miles. Now again, this is just between 40 and 50 degrees south latitude. Now, if we figure this with the adjusted Antarctica circumpolar current speeds and add another 4 miles per hour with 11 miles per hour, we would get 264 miles, and the 264 miles per day times 260 days would be about 68,640 miles. And this still not including if this race was extended further out to between 60 to 70 degree southern latitudes, which again, this is just a hypothetical to give a better idea of what distance could be navigated around the coastline of Antarctica, as there is too much ice to navigate around the 60 degree latitude. But even with what we already calculated with the 43,680 miles at just the 40 to 50 degree latitudes without the added boost of the currents, that this distance is navigated nearly 20,000 miles further than the official distance of 25,000 miles of the Vendée Globe race, and nearly double the distance of the Earth's alleged equator circumference. It's quite interesting that the one globe race that does not use GPS technology and does not follow GPS meridian distance corrected waypoints, but only uses physical waypoints, navigates nearly 20,000 miles further than the globe races that use GPS and GPS waypoints with distance corrections, but I'm sure that's just a big coincidence. We can also take the latitude and longitude coordinates from the Venn-D globe race route map and plot them on a flat-azimuthal equidistant map. This route would look something like this. You can see they are still starting at France, heading down to Cape Town, Africa, then to Cape Llewellyn, Australia, then over to Cape Horn, South America, and finally back up to France to finish the race. They would be following along the interior circumference of Antarctica rather than outside of it. And again, they would be following the many different pre-coordinated GPS boundary waypoints throughout the planned route of this trip. These GPS boundary waypoints have built in GPS meridian distance corrections, so the speed and distance they are navigating will not be accurate, as the meridian distance correction affects their GPS reported speed traveled between the waypoints, which then alters the overall distance traveled on the circumnavigation. This is all planned by design and pre-coordinated into the GPS infrastructure to hide the true distances below the equator, while also hiding the true nature and vast length of the Antarctica coastline.
This is the ocean currents according to the flat Earth map and also according to the globe. Calculating the speed of these ocean currents not easy. The main current in the Southern Ocean is the Antarctic Circumpolar Current, ACC. The ACC is the biggest current in the world and can transport up to 150 billion liters per second of water and reach speeds in narrow channels of up to 1 meter per second. But how do we calculate the speed of the currents? In this National Ocean Service webpage says that to measure currents, you need 3 basic tools: an observer, a floating object, or a drifter, and a timing device. An observer stands on a ship, throws the drifter into the water, and then measures the time that it takes that object to move along the side of a ship. As technology improved over time, oceanographers began using mechanical current meters. A ship would deploy a meter, and usually some sort of rotor would turn and measure the currents. This is still the basic process today. However, there are more accurate and sophisticated instruments. This current around the Antarctica is the biggest and the fastest one, as this professor explains.
So I've mentioned several times that the Southern Ocean is special because it has no zonal boundaries. It's a complete channel. Since the Southern Ocean is a channel, winds can keep on churning it. So the main features here are the Antarctic Circumpolar Current, one of the more famous currents. It's also known as the West Wind Drift, and it's the only current to completely go around the Earth because of the special channel configuration of this ocean. And this obviously moves more water in terms of sphere drips, the transport, than any other current in the world, right? So look at this figure carefully. It is showing multiple convergences and divergences here. So you have the Antarctic Circumpolar Current outside, or the West Wind Drift.
As a matter of fact, in this National Geographic website, they call the ocean currents as ocean conveyor belt. They are similar to the jet streams. Once you are flying with the jet stream or sailing along this oceanic conveyor belt, you have no friction because you are moving forward with the current and not against it. So to better explain, let's imagine a person standing on a conveyor belt, walking conveyor belt, found in airports all over the world. So as you observe this person, he is just standing on the conveyor belt, and in 28 seconds, let's see how many people will go by in front of the screen if the person only stands on the conveyor belt. On example number 2, we will see this person walking, and you can see how much faster he moves from left to right. And in this example, we're going to see a person going the opposite side. As you can see, he remains on the same spot, no matter how hard he tries to go against the flow. So that's why they always organize this race going from west to east, because they will go with the flow. They're going to go with the ocean currents, especially this Antarctic current, which is one of the biggest and fastest one, and that's the way they will be going from west to east.
And the globe races that don't use GPS only becomes more apparent. Now let's get into some more information on the GPS meridian distance corrections that have been cited in GPS papers dating back to the 1990s. Many of these papers were analyzed by GPS experts and analytics at that time, only to find many different issues that the GPS was not accounting for, and having to make corrections in order for the GPS to function on a globular coordinate system. At this time, from the correspondence between different letters, documents, and papers. These corrections were never directly addressed, ignored by academia multiple times, and have since been swept under the rug and not addressed. Among some of the many of these corrections were corrections for Sagnac effect, relativity simultaneity, and latitude meridian distance corrections. One particular paper written was the GPS, and the constant velocity of light published by Newton Physics.
GPS synchronization has been verified in numerous experiments. It is identical to the calculations presented in this paper, and also to the Sagnac effect, which is included in the GPS. Among the list of the corrections, there is a correction involving a parameter taking into account how many Earth meridians are crossed by the path of light or by a moving clock move between the what?
Wait, what?
What? Yo.
Clock.
Whoa. Whoa, red flag.
Meridian again?
Red flag. So the latitude line. So every time it crosses the lines, like
it says
right here.
The correction involving a parameter taking into account how many Earth's meridians.
So anytime it crosses one of these lines, Toby.
There's another account for it, right? Another parameter that they add into it.
Dude, Toby, we're never gonna be able to get the distance using GPS, dog.
No, of course not, dude.
No, look at this. Not. Literally to the fucking meridian, bro.
Among the GPS list of corrections, there is a correction involving a parameter. There is a correction involving a parameter taking into account how many Earth meridians are crossed by light. Dude, wait, so GPS signals are based on by numerous experiments and identical to the calculations. Where can we pull that? I would like to pull that other one up at some point. Maybe I can pull it up on my own.
The clock synchronization thing?
I want to see that, but we're never going to see that. They're not going to show that.
The clock synchronization. Oh my god. Dude. No, we have to go look right now. Because if that's in there, what was that document called? I highlighted it in green.
You got it marked in green, yeah.
Yeah, it's
oh wait, no.
Down here.
I think it was towards the top. I thought. There it is.
No, not that one. That's close though.
There it is.
This one right here. Yep.
Yep.
We're gonna go pull this up.
Like, if we can find that, that will be pretty cool.
Dude, correcting to the meridian, bro. Get the F out of here. You could never, ever say anything about, oh, we use reciprocal GPS angles. Sorry, buddy.
You're missing the point. If we lived on a plane and then somebody projected it onto a sphere, there would be latitude and longitude for every location on the plane Earth on the sphere.
That's literally how we created
That's how
the
they
way
do
that
it.
we created latitude. Was we took angle measurements to Polaris down to the ground. We took elevation angle measurements to Polaris. So we have a ground position directly under Polaris. Like if you were to get to the North Pole, which by the way, you can't go there, then Polaris would be at your zenith, right? That's a ground position. And then what we did was we took angle measurements with our horizontal baseline going out to the ground position and then going up to Polaris and then an angle to that. And what we did was bring that angle down to the ground and we kept on making these measurements further and further away from Polaris, and we created the latitude system with concentric circles around the North Pole. Then we took that and we put it onto a globe. Then we took the globe and then we put that into a cylinder, and then we flattened the cylinder out, and that's where we get the Mercator map. So the actual origin of the latitude system is a flat Earth set of measurements. It's transformed into a globe. The difference is going to be when you get really far south. The longitude is going to begin to compress down on a globe, converge back down, right? But on the flat Earth, it's not going to do that. So to really test the difference, you're going to have to get far enough out south, which conveniently you also can't do that. So longitude and latitude work on a flat Earth. They're actually created from a flat Earth. Latitude's created from a flat Earth. And actually GPS and satellites and all this, they make meridian corrections in the south. They make meridian corrections to even get the right location and distance for the GPS satellites, which shows you that the globe doesn't work in the south.
Well, and think about this. You said that it's down to the minute or down to the second that you said sunrise and sunset, but we just got done telling you that refraction means that the sun's not actually there. So it isn't mathematical. It can't be, or else you're going to be off by a half a degree every day. It has to be. The sun's not
changes
actually
every.
Yeah, because they're all shown this. They're all shown the relativistic framework. Once they have that lens of interpretation, any varying speed of light, they can just start invoking different quote unquote relativistic effects. And so back to real quick on the satellite coordinate system transformation. So the initial, sorry. So the original coordinate system that they that everything is derives accurate distance under, when they transfer out of that, that's when you can get into things like hiding distances or adding, spherical excess and stuff like that, because they're in a completely different coordinate system. They just need to make it match like in local areas, right? So like in a city, like there would be a different coordinate system for that. It would be more accurate. And then if you were traveling over a long distance, highway span or whatever, they could adjust distances like that. And you would think, you're traveling X amount of distance between this city. And then when it matches locally to the thing, you assume the whole thing is, but you don't realize that it's literally doing constant calculations of coordinate. It's just coordinate system transformations that are all based off of an original preferred directional speed. Thank you for the time. I appreciate it.
I wanted to talk a quick minute about GPS. And sorry for my scribbles, but hopefully this will help you understand a little better. If the map on the left was the correct map, and we needed people to think that they are on a globe, then you would put ground-based tracking everywhere. So let's call that those red sticks on the map on the left. Then when someone stands, say, at the 3 dots in South America, then it would coincide with our GPS or global positioning system, which would be the 3 dots on the right. We could just say that those 3 dots were being tracked by big metal satellites orbiting above your head, when in actuality they were ground-based stations. Now, if someone thinks that they are going from, say, South America to Antarctica, on the right, they would actually be just doing the same thing as we see on the left. Same thing with Australia. Going from Australia to the South Pole would look the same way on the left as on the right. And as people fly around the world, the GPS simply tells them where they're going. So even though you're just doing a big circle, the GPS makes you think you're on a globe. So,
against to give that amplitude to the fringe.
I think the biggest thing is that
it absolutely does.
in the GPS satellites being, or the GPS code being closed source. And every time I say that, I see people in the chat saying, it's not closed source. Here's a link, here's a link, here's a link. No, I'm not saying that it's not a code that you can implement in your device. It is, but the transformations, the numbers, the mathematics is not for you to see. So if you lived on a plane and you needed to return to somebody where they would be on the globe, what you would do is you would have those mathematics embedded in your balloons or whatever you're using, so that when a signal is sent from there and you are saying, here I am on the Earth, they say, here you are on the globe. And that's it.
Bro, I did a presentation on that recently. That's exactly how it would work. So when I said, I mentioned earlier, like a shadow coordinate system, that's exactly how it would work. It would all be relative to the center of the ECI. So you would take like the center of the North Pole, right? You would have everything out from there. You would have its accurate position and everything in real space relative to the actual map of everything. And then you would have that projected onto a globe, right? And the difference in there would all be encoded in, then you would just do your scale invariance. So when people see a satellite move across the sky at whatever speed they say, they're like, oh yeah, it's proportional to it going across the speed at that distance, but the altitude could be vastly different. But the signal that they send is it's encoded with the information that the satellite is coming from 22 kilometers out, right? So it's already backwards compatible with it on the back end. And in addition to that, you would already have it work that way, and not even necessarily for nefarious purposes, for military reasons, right? Because you wouldn't want to have somebody, of course, be able to actually derive the altitude of your satellite so they could attack it or something like that, right? Its actual position. So you would have it, that would already be built into it. And then on top of that, I don't know if you noticed, Jaron, but they have what's called meridian corrections built into the signal time. So it deduces like how long the time was taken, and it applies a meridian correction. So it's basically like how long the speed of light would, if it propagated for X amount of time, how many meridians would it have crossed, and they adjust the time of that, thereby or thus adjusting the distance. So like you can't even use GPS to get an accurate reading over long distances, because it's always going to go back to the globe, but it's going to be super accurate short distances. But that's how they're going to hide it. Correct. True. When you try and check over long distances, it's going to be globular.
Yeah, these guys are like, show me a plane that's going 1,200 miles per hour. I can't, because you believe in the GPS distances.
Dude, yeah, it gets super hard with that because it's already corrected and baked in. Like I was reading this paper from the 90s where these gentlemen wanted to go and look at GPS corrections to verify the speed of light is the same in all directions. So when they did their analysis from the raw GPS data from the main central place in Colorado where they store all the data, the data that they got was already SAGNet corrected, doing air quotes. I'm sorry, my green screen is blocking it out, but it was already quote unquote SAGNet corrected, and they say that this is due to the rotation of the Earth and whatnot.
It doesn't make any sense.
Not to get into the full specifics of that, that's absolutely not the case. And what they're actually doing in that data is applying first order velocity corrections to the speed of light to make it seem like on the GPS end that the speed of light is the same and it's deriving the distance based off of that constancy. That's not true. They already corrected it on the back end before anyone even gets to see it. So the idea that like you can just go to an open source, dude, I'm going to go to GitHub and debunk the globe.
Yeah, Jesus.
Yeah, miss me with that. You know what I'm saying?
No, and then that guy that we had the interview with, Austin and I were talking to him, and he's like, yeah, but it works. It's like, yeah, it works. That's the deception. Like, you shouldn't be surprised if we're saying, hey, you're being deceived, and then you're like, yeah, but it works. Yeah, we know that. That's why it's a deception. If it didn't work, we wouldn't be having this conversation. Nobody would have ever believed it.
At this point, we have learned that these globe races and modern-day circumnavigations of Antarctica are not even close to what we're told they are. We are now aware of the many different ways that they hide the Antarctica coastline with magnetic declination and GPS safety boundary waypoints, and also use GPS meridian distance corrections below the equator to manipulate the overall mileage, distance, and time duration of these expeditions. From what we now know about all of the specific mileage logs on these historic circumnavigations of Captain Fabian Bellinghausen, Captain James Clark Ross, and Captain Cook, all logging between 51,000 miles to over 60,000 miles around the 5270 degree latitude, as well as the modern-day Golden Globe race. Navigating a calculated distance of over 43,000 miles on only around the 4250 degree latitude, which mathematically would be closer to 50,000 to 60,000 miles around the same 60 degree latitudes as the previous explorers, we start to notice a recurring pattern of a similar navigated distance. Between all four of these circumnavigations, the fact that the one single modern globe race that does not use GPS meridian distance corrections navigates almost the exact same distance as Captain Cook's first voyage and a very similar distance to all three historic explorers' circumnavigations cannot be a mere coincidence. Once you get a glimpse behind the wizard's curtain and see how the magic trick is done, all of the pieces of the puzzle start to come together, and you realize that these circumnavigations only further prove the vastness and immensity of our majestic flat Earth.